morning again. How are you, my kids? It's Murad Sultan Azwili again with you. Yesterday we saw how can you reflect shapes and let's say in the line y equal x and y equal negative x and in the y-axis and x-axis using of course algebraic techniques and not geometric techniques. Okay, we stop at this point. Today we'll try to continue rotating or transforming shapes using rotation 90-degree clockwise or anti-clockwise, okay, about the origin, then 180-degree about the origin of course, and 270-degree anti-clockwise about the origin, okay, and so on. Then we move to the enlargement. So please, my kids, don't forget first to join your classroom, okay, and try to interact with the worksheets that I already gave, okay. And it worksheets is 4 out of 4 or 3 out of 3, okay. This depends on the number of the questions, okay. So please don't hesitate to do your assignment sheets and send to me, okay. Thank you for that. Now we start. The lesson is what, my kids? Matrices for rotation, okay. So before, my kids, we saw what exactly? Matrices for reflection. For what? For reflection, okay. Matrices for reflection, okay. Matrices for what? For reflection, okay. Matrices, okay, for reflection, okay. We saw what exactly? We saw in the x-axis, in the x-axis, then in the y-axis, then in the line y equal x, and in the line y equal negative x, okay. So now we will continue how can we use matrices to rotate or to enlarge, okay, shapes. Okay, the matrices derived for rotation are defined for an anti-clockwise rotation about the origin. Anti-clockwise or counter clockwise, okay. So about what? About the origin of coordinates. Origin is 0, 0, okay. In each case, the matrix A, B, C, D represents an anti-clockwise rotation about the origin. Also, we should know that a counterclockwise or an anti-clockwise rotation of 90-degree is the same as a clockwise rotation to 170-degree. So we need not to derive matrices for clockwise rotation. Okay, we try to work with counterclockwise or anti-clockwise rotation. Okay. And in general form, to find any coordinates of the point A, let's say in the rotation about the origin 0, 0 and 90-degree. So just you will use what we saw before. A, B, C. This is a matrix, a square matrix of order 2 or a matrix of order 2 by 2. Multiply by what matrix? Multiply by the column vector of the element of the point should be equal to the color vector of the image. Okay, the vector of the image. So let's continue. In general, matrix for rotation is the matrix of rotation. This is A, my kids. This can be written as A, B, C, and D. Where A equal cosine of theta, B equal cosine of negative theta, and C equal cosine sine of theta, and D equal cosine of theta, whatever be the angle theta. Okay. So, in general, I always try to work with this point, my kids, with the point 1, 0, and what else? And this point is 0, 1. Okay. So, if theta equal 90 degree, the matrix for of transformation or the matrix for rotation 90 degree anti-clockwise above the origin is cosine of 90. Cosine of 90 is 0. Minus sine of 90 degree. Sine of 90 degree is 1. So it will be minus 1. Then sine of 90 degree is 1. And cosine of 90 degree is 0. Okay? So this one is very important, my kids. Okay? So, if theta equal 90 degree, the matrix is 0, 1, negative 1, 0. Okay, let's check, my kids. Let's start with the point 1, 0. 1, 0. This is 1, 0. Okay, I will rotate this shape 90 degree. Okay, it will be what? 90 degree. Okay, anti-clockwise like that, from right to left. This point has the coordinates 1, 0. When it rotates 90 degree, it will be what? It will be this point. It will be 0, 1. So 1, 0 maps to what? Maps to the point of coordinates 0, 1. Okay? So 0, 1. I will just write here 0, 1. Then the next one. So in order to find AC, I should multiply this matrix by the column vector 1, 0. 1 A multiplied by 1 is A. Okay? And C multiplied by 1 is C. So equal what, my kids? Should be equal to 0, 1. So you can, these two matrices are equal. And they have the same order. You can equating their corresponding elements or numbers or value or entries. So it means A equal 0 and C equal 1. Okay? So A equal 0, C equal 1. For the next one, for 0, 1, this point, my kids, 0, 1, I will rotate it 90 degree anti-clockwise. So the point will be what? The coordinates of this point will be minus 1, 0, isn't it? Minus 1, 0. So this is, my kids, the second column vector. The second column, it will be negative 1, 0. This is in fact my matrix, okay, for rotation anti-clockwise about the origin 90 degree. Okay, 0, 1, 0, 1, minus 1, 0. Okay, you can also use this by substituting in this trigonometric function theta equal 90 degree. Okay, then for the next one, we thought 0, 1 maps 0, 1 maps to what? Maps to negative 1, 0. Okay, hence that the matrix for transformation that transform this point to its image. Okay, so it will be A, B, C, D times 0, 1, the coordinates of this point, that maps in fact to this point, which has coordinates of negative 1, 0. Negative 1, negative 1, 0. Okay, now my kids, if you would like to work out B and D, because A and C we found the value of A and C. Now we would like to find the B and D. So just multiply
A by 0 is 0. B multiplied by 1 is B. Okay. Then C by 0 is 0. D multiplied by 1 is D. 0 plus D is D. Okay. Equal what? Equal negative 1, 0. So, both matrices are equal. Okay. And they have the same order. You can, let's say now, equate their corresponding entries. Means B equal negative 1. Means B equal what, my kids? Equal negative 1. And D equal 0. So, this one represents what? My matrix of transformation of a point, for example, A of coordinates 1, 0 to its image, it will be 0. And from 0, 1 to negative 1, 0. So now at least we can work out this matrix that transform A into B. Okay? And the rotation, of course, about the origin, 90-degree, counterclockwise or anti-clockwise. So the matrix for an anti-clockwise rotation about the origin through 90-degree is 0, 1, negative 1, 0. Is 0, 1, 0, 1, negative 1, 0. Okay, in general, my kids, if you'd like to transform or to find the image of any point, okay, through, let's say, and the rotation, okay, about the origin 0, 0 and through 90-degree anti-clockwise, okay. So we should use this matrix for transformation and multiply by the coordinates given of this point. You will find the image. Okay. So here we have an exercise. One volunteer carried the exercise. The triangle A, B, C has coordinate of 1, 1, 2, B, 1, 4, B, 1, 4, B, 1, 4, then, and C, negative 1, negative 3. Determine the coordinates of the image of the triangle A, B, C in the rotation about the origin through 90-degree. Through what? Through 90-degree. Through 90-degree. Okay? So, first of all, before guessing what is the exactly the coordinates of their image, we should work out or write your matrix of transformation. The matrix that transforms this point to its image. So the matrix is what? For rotation, of course. We told that 0, 1, y 0, 1, look. This is the x-axis. This is y. This is 0. This is 1, 0. Okay. This is 0, 1. Okay. And this is what? Negative 1, 0. We told what, my kids? We told this point has transformed here about the center 90-degree. Okay. And this is the center. So the coordinates of 1, 0 will be 0, 1. So this is 0, 1. Then this is the next point. I will rotate this one here, my kids. Okay, 90-degree anti-clockwise about the origin. It will has the image will be negative 1, 0. So this one, my kids, is your matrix for rotation 90-degree anti-clockwise about the center of the rotation, which is the origin. Okay, so we have 1, 2, negative 1, 3. 1, 2, negative 1, 3. 1, 2. Then negative 1, 3. Negative 1, negative 3. Okay, what else? We have, okay, and 1, 4. 1, 2, negative 1, negative 3. 1, 4. Okay. And we have 1, 4. So, this one, my kids, is what? This is, okay, this is A. Okay, this is C. The coordinate C. This is the point
B of coordinates 1, 4. Okay. Now, the matrix for rotation about the origin through 90 degree, my kids, through 90 degree. So here we have an exercise. Okay, A of coordinates 0, 2, B of coordinates 1, negative 3, negative 4, and C of coordinates 1, 3. Okay, so 0, 2, 1, negative 4, 0, 2, 1, negative 4. Okay, 0, 2, 1, negative 4. Okay, this is A, this is B, and this one is, okay, C is what? Coordinates of the point C is 1, negative 4, 1, 3. 1, negative 4, 1, negative 4, 1, 3. Okay, here we have 3 points, or the three vertices of a triangle. I want to transform A, B, C, okay, and the rotation about the origin through 90 degree. Okay, through 90 degree. So first of all, you should think of what? Of the matrix that transform this triangle, okay, into its image. Okay, so it will be what? We told that, look. Okay. This is 1, 1, 0. It will be 0, 1. Here, this one. 0, 1. So the first one is 0, 1. The next it will be 0, negative. If you rotate, this is 90 degree about the center. Counterclockwise, it will be 0, negative 1. This is your matrix. Sorry. Okay. It will be, my kids, minus 1, 0. Okay? Minus 1, 0. Okay. So, now I will write what? I will write my matrix. Okay? It will be 0, 1, then minus 1, 0. Multiply by what? By the coordinates of A is what, my kids? Is 0, 2. Okay. Right. This one as it can be. Then just multiply. 0 by 0 is 0. Negative 1 by 2 is negative 2. Negative 2 plus 0 is negative 2. Then 1 multiplied by 0 is 0. Plus 0 multiplied by 2 is 0. So this one. Hence the coordinates of A is what? Is 0, 2. And this is maps to what? Maps to 0. Maps to what? This one, yes, maps to negative 2. Okay, negative 2. Negative 2, 0. Okay. The next one. Here we have 0, 1. Then we have negative 1, 0. Okay. I will try to transform the point B of coordinates 1, 1, negative 4 in the rotation, okay, through the origin, or about the origin, through 90 degree counterclockwise. Okay, so this is the matrix for rotation 90 degree. Okay, so multiply by what? By 1, negative 4. Just multiply. 0 by 1 is 0. Then negative 1 multiplied by negative 4 is 4, my kids. Okay. 1 multiplied by 1 is 1. Plus 0 multiplied by negative 4 is 0. 1 plus 0 is 1. Good boy. So just right here. 1, hence B of coordinates 1, negative 4. And that's maps to B prime is 4, 1. 4, 4, 1. Okay. The next one, we have the matrix that transform A into C prime is, yes, matrix for rotation about the origin, 90 degrees. So 0, 1, then minus 1, 0, multiply by, what are the coordinates of the point C, my kids? Is 1, 3, okay, is 1, 3. Then just multiplication. 0 by 1 is 0. Negative 1 by 3 is negative 3. Negative 3 plus 0 is negative 3. 1 by 1 is 1. Plus 0 by 3 is 0. 1 plus 0 is 1. Hence that, or now you can write down the coordinates of the C, of the image of the point C. Hence that, this is my case 1, 3. C of coordinates 1, 3. Okay. And that's maps to, that maps to C prime of coordinates negative 3. What? Negative 3. Negative 3. Okay. Then, in the rotation about the origin through 90 degree, this is 90 degree, but it's white, it's with white color. 90 degree. Triangle ABC is mapped into triangle A prime, B prime, C prime, where A prime has coordinates of negative 2. What else? 0. And B prime is 4, 1. And C prime is negative 3, 1. Okay. Here we will not use geometric techniques. You will use algebraic techniques, meaning that you will work out the entries of this matrix for rotation about the origin 90 degree. After finding out, you can multiply by the coordinates of any point to find the image. Okay, good boy. The next, enable exercises. Here we have the triangle AB has coordinates of 2, 2, 3, 4, 3, 0. Okay, 2, 2, 3, 4. Okay, 2, 2, 3, 4. This is A, this is B, and this is C. Okay, 3, 0. Okay, 2, 2, 3, 4, 3, 0. Okay, and this one, my kids, is C, 3, 0. Okay, now I will do what is it? I will try to find the coordinates of this point in the rotation about the origin through 90 degree counterclockwise or anti-clockwise. First of all, you should work out what? You should work out or figure out or write down the matrix that transform this point into their image. Okay, but the key words is what? The matrix for rotation, about the origin through 90 degree. Okay, be careful. Of course, counterclockwise or anti-clockwise is what? This is 90 degree. Okay? Okay, this is 90 degree, and this is means counterclockwise or anti-clockwise. So the first we told the point of coordinates 1, 0, it will be transformed to 0, 1. Okay, good point. This is 0, 1, my kids. Then the next will be negative 1, 0. This is my matrix that transform matrix for rotation about the origin through 90 degree that transform A to its image, B to its image, C into its image. So I will just write my matrix is 0, 0, 1, negative 1, 0. Okay, 0, 1, negative 1, 0. Then 0, 1, negative 1, 0. I multiply by this matrix for rotation about the origin through 90 degree, counterclockwise by the coordinates of A first, 2, 2. Then the same I will multiply by the coordinates of B. It will be 3, 4. And the last one, it will be 3, 0. Okay. Now just I will make the product to calculate or to find the product of these two matrices. 2 by 2 and 2 by 1. Okay. 0 multiplied by 2 is 0. Negative 1 multiplied by 2 is negative 2. Negative 2 plus 0 is negative 2. 1 by 2 is 2. Plus 0 by 2 is 0. 2 plus 0 is 2. So hence that the coordinates of A is 2, 2, maps to A prime of coordinates negative 2, 2. Okay? Negative 2, 2. Okay. The next. 0, negative 1, 1, 0 multiplied by the Cannon vector. 3, 4. So 0 multiplied by 3 is 0 plus negative 1 multiplied by 4 is negative 4. 0 negative 4 is negative 4. 1 multiplied by 3 is 3 plus 0 multiplied by 4 is 0. 3 plus 0 is 3 plus 0 is 3. So hence that B of coordinates 3, 4 and what? And that maps to B prime of coordinates negative 4, 3. Okay. The next, the coordinates of the point C. So 0 minus 1 multiplied by 3, 0. It will be 0 by 3 plus negative 1 multiplied by 0 is 0. 0 plus 0 is 0. 1 multiplied by 3 is 3 plus 0 by 0 is 0. 3 plus 0 is 3. Hence that this one it will be 3, 0, my kids. C of coordinates 3, 0 maps to what? C prime of coordinates 0, 3. Then, as a conclusion, in the rotation about the origin through 90 degree, triangle ABC is mapped into triangle A prime, B prime, C prime, where A is, we found A, my kids, is what? Is negative 2, what? 2. Good boy. And B prime is negative 4, what? Negative 4, 3. Good boy. And C prime has coordinates of 0, 3. Okay? The next. Okay. Now we at least worked or calculated the image of 3 points or 4 points. Okay? And the rotation about the origin through 90 degree counterclockwise. And we did write or find out the matrix that transform this point into their image. Okay, when theta equal 90 degree. Okay. So here we do the same. This one, my kids, in fact, is what? Is the matrix for rotation about the origin, okay, through 270 degree counterclockwise. Okay. Look, first of all, cosine of theta. Cosine. Okay. I will write it here. Cosine of 270 degree is always 0. Okay? And sine of 270 degree is what? Is minus 1. And sine of 270, okay, yes, it will be minus 1. Means what? This is, look, this is the x-axis, this is the y-axis. This is 90 degree. So sine of 90 degree is 1. Okay? This is the unit circle. I will suppose this is the unit circle. Okay? So, and cosine of 0 is 1. Cosine of 180 is negative 1. Cosine of 270 is 0. But sine 270 is minus 1. Okay? Here we try to substitute in this trigonometric function theta equal 270. Theta equal 270 degree. Okay. So, cosine of 270 is 0. Sine of 270 is minus 1. Cosine sine of 270, this is 90, this is 90, 180 plus 90 is 270.
So sine of 270 is negative 1. But here, you look here. There is a negative sign. Negative gives positive. So that's why here is 1. And sine of theta, where theta equal 270 is negative 1. So it will be negative 1. Then cosine of 270 is 0. So this is in fact the matrix that transform any shape, okay, about the origin anti-clockwise, okay, through 270 degree. Okay, let's start first. The point 10, my kids. 10 on the x-axis. It will map to what? To 0, negative 1. To 0, negative 1. This point will move 90 degree, then 90 degree, then 90 degree. So this point, it will be what? 0, negative 1. Okay? This point, after rotating this about the origin, 270, 90 degree counterclockwise, it will be this point. So 0, negative 1. Okay. 0, negative 1. Okay. So this is that. The matrix that transform this point on its image, okay, I will write the relationship between them. So A multiplied by 1 is A. Then C multiplied by 1 is C, equal 0, negative 1. So these both matrices are equal and have the same order, means A equals 0 and C equal negative, means A equals 0, and C equals negative 1. That's why here we should write 0, negative 1. Okay, for the next one. 4, 0, 1, this point, my kids. It will move we will rotate this point about the origin counterclockwise through 270 degree. This is 90 degree, okay? This is 90 degree, 108, and this one 90. So it will be like that. It will be this point. Means this has the coordinates of 0, 1. After rotating this about the origin counterclockwise through an angle of 270 degrees, it will be what? It will be 1, 0. Okay? It will be 1, 0. So we told that this point 0, 1 maps to the point 1, 0, 0, 1, x equals 0, y equals 1. Maps to this point. Okay, then I will try to find B and D. I will use this matrix of transformation that transform this point to its image. To find B and D, because A and C we already found it. Found it. Okay, so then just I will multiply this by that. A multiplied by 0 is 0, plus B multiplied by 1 is B. Good boy. Then the next C multiplied by 0 is 0, D multiplied by 1 is D. Should be equal to what, my kids? To 1, 0. Now you can equate both matrices. Why? Because both of them are equal and both of them have the same order. So just equating their corresponding entries means what? B equal 1. B equal 1 and C equal what? C equal 0. Okay, so I found now my matrix for rotation about the origin through 270 degree counterclockwise or anti-clockwise. I will just write it here, which is 0, negative 1, 1, 0. So the matrix for an anti-clockwise rotation, for an anti-clockwise means counterclockwise. Okay, rotation about the origin through 270 degree is 0, negative 1, 1, 0. Is 0, negative 1, 1, 0. Okay. This matrix helps you to find the coordinates of the image of any point. Okay? Let's investigate. Okay. So, first of all, what is your matrix of transformation? Yes? This is 0, my kids? This is 0. Because Cosine of 270 degrees is 0. Cosine of 270 is 0. Sine of 270 is minus 1. So minus sine of 270 is minus 1 is 1. This is the matrix for rotation. This one is matrix for rotation. Matrix for what? For rotation. Rotation. 4. Okay. You can write like that. Okay, we told that matrix for anti-clockwise. Okay, matrix for an anti-clockwise rotation okay, about what? About the origin. Through what? Through 270 degree. Okay? This is the matrix. This one helps you to find the coordinates of any point. If, for example, this point B, of course, 3, 2, I will just make here 3, 2. Then I will calculate it. 0 by 3, 0. 1 plus 2 is 1 multiplied by 2 is 2. Then minus 1 multiplied by 3 is minus 3 plus 0 by 2 is 0. So this is, I immediately using matrix transformation to transform B into B prime. I just multiply the matrix for rotation about the origin anti-clockwise through 270 degree of this point. I found this one. Okay? Let's do it. Okay. This one my kid says a homework. Think about it. This is a homework. Okay. This is a homework. Please do it. Now I will give you an exercise. A of coordinates 0, 1. B of coordinates 1, negative 3. C of coordinates 7, 7. Okay? I will try to find the coordinates of these points. Okay? And the rotation about the origin counterclockwise through an angle of 270 degree. Okay. So first of all, I should write the matrix for this transformation, for this rotation. Okay, the matrix for rotation about the origin through 270 degrees. What? We told 1, yes, negative 1, sorry, 0, we told 0, then this is 1, 0. Okay? This is the matrix that transforms any point in the rotation about the origin through 270 degree. Okay. Zaid Ibrahim, the first one. I will just write here what? 0, minus 1. Then this one it will be 1, 0. Multiply by what? Yes, Zaid, multiply by the coordinates of this point A. But try to write as a kind of vector. It will be 0, 1. Good boy. Then 0 multiplied by 0 is 0. Plus 1 multiplied by 1 is 1. 0 plus 1 is 1. Okay, good boy. Then minus 1 multiplied by 0 is 0. Plus 0 by 1 is 0. 0 plus 0 is 0. Now, I use the matrix for rotation about the origin through 270 degree counterclockwise of this point. I found the image. Means that, so A of coordinates 0, 1 and maps to A prime of coordinates 1, 0. Good one. Then, the next one we have 0, negative 1, 1, 0 multiplied by what? Multiplied by the coordinates of the point B, my kids, is what? Is 1, negative 3. Then, just find the product of these two matrices, you will find the image. So this one will be negative 3y, Ammar. Why negative 3? And this one gives negative 1, y. That is the question. Why exactly? Automatically move to multiply the first row by the first column. Means 0 multiplied by 1 is 0 plus 1 multiplied by negative 3 is negative 3. So 0 negative 3 is negative 3. Okay, the next, multiply this by this column. Minus 1 multiplied by 1 is minus 1. Plus 0 multiplied by minus 3 is 0. Minus 1 plus 0 is minus 1. So, I will just write, hence that B has a coordinates of 1, negative 3. And B prime maps to B prime is negative 3, negative 1. Okay? The next one. 0, 1, 0, negative 1, this is my matrix, or the matrix for transformation about the origin anti-clockwise through an angle of 270 degrees. Okay. Multiplied by what? Multiplied by the coordinates of the point C, which is 7, 7. Okay? 7, 7. Now we multiply this, it will be 7. This one it will be what? Negative 7. Why negative 7? Because 1 multiplied by 7, 0, plus 1 by 7 is 7. Then negative 1 multiplied by 7 is negative 7. Plus 0 multiplied by 7 is 0. Negative 7 plus 0 is negative 7. So I will just write this here as 7, 7, 7. And here it will be 7 negative 7. Okay, 7, negative 7. Okay, now enter the rotation about the origin through 270 degrees. Triangle ABC is mapped into triangle A prime, B prime, C prime, where the coordinates are A, B prime, C prime, we already calculated. So it will be 1, 0. Then here it will be negative 3, negative 1, and plus 1, 7. 7 and negative 7. 7 and negative 7. This is negative but it's not clear. I will clarify it. Okay, negative 7. Okay, the next one, my kids. Here we have another example. Okay. Minus 1, minus 2, 0, 4. Minus 1, minus 2, 0, 4. Minus 1. Minus 2 and 0, 4. Okay, this is A, this is B, and this one is C. C of coordinates 2, negative 3. C of coordinates 2, negative 3. Okay. 2, negative 3. So, here we have 3 points. A matrix for rotation about the origin through 270 degrees is what? Is called 0. Yes? 0 minus 1. Then 1, 0. I will try to multiply this matrix by the column vector of this point A to find the column vector of its image A prime. Then I will immediately move to multiply this matrix for rotation about the origin through 270 degrees by the column vector of this point to find the image of this point, okay? And C also. So, shall I write here the matrix for transformation? It will be what? 0. It will be, sorry. It will be, my kids, 0, 1, negative 1, 0. Okay. This one it will be negative 1, and this is negative, negative, gives positive. Okay. Positive 1. Okay. So, multiply by what? The coordinates of this is what?
is negative 1, 2. Negative 1, 2. Okay, negative 1, negative 2. Okay, then multiply this by that. It will be negative 2. Why negative 2, Mariam? Because 0 multiplied by negative 1 is 0. 1 multiplied by negative 2 is negative 2. 0 plus negative 2 is negative 2. Then, the second one, this multiplied by this gives 1. Why? You know, because negative 1 by negative 1 is positive, plus 0 by negative 1 is 0, so 1 plus 0 is 1. Good boy. So, minus 1, I will just write here the coordinates minus 1, minus 2. Then this maps to A prime with the coordinate of negative 2, 1. Then the next point, to find the coordinates of the point B, just write this as a kind of vector and multiply by the matrix for rotation about the origin. Okay, anti-clockwise 270 degree. You will find the B prime, the image of the coordinates of the point B, which is labeled as B prime. Okay, so I'll just write 0 minus 1, 1, 0 multiplied by what? By 0, 4. Good boy. Then this one gives 4, only 4. Because 0 by 0, 0, 1 by 4 is 4. 4 plus 0 is 4. This one minus 1, 0 multiplied by this gives 0. Okay, minus 1 by 0 is 0, plus 0 by 4 is 0. Add the 0, it will be 0. Hence that B has the coordinates of 0, 4, and B prime has the coordinates of 4, 4, 4, 4, 0. Then, the next, 2, negative 3. This is 2, my kids. This is negative 3. Okay. This is 0, negative 1. This is 1, 0. Multiply this by that. Think it is a rotation. Think that is a rotation, please. About the origin. Okay, through 90 degree. Okay. So, we thought that this one gives only negative 3. Why negative 3? Because 0 by 2 is 0, plus 1 multiplied by negative 3 is negative 3, negative 3 plus 0 is negative 3. Then, this one, negative 1 multiplied by 2 is negative 2, plus 0 multiplied by, plus 0 multiplied by negative 3 is 0. 0 plus negative 2 gives negative 2. So, just I will write here, hence C of coordinates 2, negative 3 maps to what? Maps to C prime of coordinates negative 3 and negative 2. Good boy. Then you can write the coordinates of this point, which is A, we have negative 2, 1, B prime is 4, 0, and C prime is negative 3, what else? Negative 2. Okay, we can see that. And then the rotation about the origin, 90, not 90 degree, 270 degree, this one, 270 degree, okay, 270 degree, triangle ABC is mapped into triangle A prime, B prime, C prime, where A prime, you already calculate its coordinates, so we wrote it down here, negative 2, 1, B prime, we already calculate this, and you should write it down there for 0, and C prime, negative 3, negative 2. Okay, I wish that at least you have an idea how can you use algebraic techniques rather than using geometric techniques, because this one obliges you to work with the matrices, okay, matrix transformation, okay. Then the next one, my kids, we have what? The next example. Now let's see when theta equal 180 degree. When theta equal 180 degree. Let's see the matrix for transformation. Okay. The matrix for an anti-clockwise rotation about the origin through 180 degree. Okay. So, I will start from the point 1, 0. I will transform this point 1, 0. Okay, through the origin 180 degree. This maps to what, my kids? This is 1, 0. This is the point 1, 0. 180 degree
This is 90, this is 90. So it will be, what are the coordinates? This is 1, 0, okay? So it will transform, okay? It will be maps to new coordinates, which is negative 1, 0, okay? Negative 1, 0. So the first one, the first row, let's say the first column vector is negative 1, 0. Okay. Then, this point, my kids, 0, 1, it will transform it or rotate it about the origin. 0, 0, 180. This is 90, this is 180. So 0, 1 will be, this is 0, 1, my kids, 0, 1, 0, 1. It will be maps to what? It will map to what? To point of coordinates 0, negative 1. Okay, 0, negative 1. So the first one it will be 0, negative 1. Okay? You can see that this is my matrix that transforms this point to its image and this point to that. Okay, I will use this one. Okay, but cosine of 180, my kids, is cosine. Look, cosine of 180 degree is equal to negative 1. This is negative 1, this is 180 degree. Cosine of 180 degree in the unit circle is negative 1. And cosine of 0 is 1. Cosine sine of 90 degree is 1. Sine of 270 is negative 1. Okay. So, and sine of 180 degree is 0. Okay, is 0. So, just right here, what? Cosine of 100 is negative 1. This is 0. This is 0. This is negative 1. This is, my kids, the same matrix. I will just substitute in this trigonometric function inside the matrix. I put theta equal 180 and I found its value. So if theta equal 180 degree, the matrix for an anti-clockwise rotation about the origin through 180 is negative 1, 0, 0, negative 1. Okay, don't forget about this matrix. For rotation 180 degree about the origin is negative 1, 0, 0, negative 1. Let's say, grasped to this matrix, you can work out the image of any point. Okay? So, anti-clockwise rotation about the origin through 180 degree. Okay. We start from the first one. We told 1, 0, the point 1, 0, 1, 0, maps to negative 1, 0. Okay? Negative 1, 0. So, negative 1, 0. Hence that the matrix that transforms this point to that is labeled as A, B, C, D. In this part, I will try to work only the value of A and C. I will just multiply the product of two matrices. Will be A, then here C, equal what, my kids? Equal minus 1, 0. Both matrices are equal, having the same order. A equal negative 1, A equal negative 1, C equal 0. So I found the first one. What is it? Negative 1, what is it? A equal negative 1, C equal 0. Okay. Then, so A equal negative 1 and C equal 0. We need what? We need to find also the value of B and D. We should move to the next point. With convenience, we told that we will use this point and this point. Move now to the point that lies on the y-axis of coordinates 0, 1. This is 0, 1, my kids. This point maps to what? This point, it will rotate about the origin 180 degree. It will map to 0, negative 1. Good point. 0, negative 1. So, here, a matrix transforms this point 0, 1 2, 0, negative 1. I should find this matrix, this wonderful matrix. I should find it out. Okay? So, in that, this is the matrix. In this matrix, I will just find the value of B and D. Why? Because A and C, we found it from the first point that lies on the x-axis. We found the first row, the value that lies on the first row, first column, second row, first column. Okay? Now, if you like to work out the value that lies on the numbers or the element that lies on the first row, second column, second row, second column, you should use the point that lies on the y-axis. Okay. So, we thought that this matrix multiplied by the coordinates of 0, 1, okay, give us negative, give us 0, negative 1. The image of the point, okay, for rotation, in the rotation about the origin 180 degree. Then multiply, just we make A multiplied by 0, no need to write it. B multiplied by 1, I will write it B. Then the next C multiplied by 0, no need to write it. D multiplied by 1, just write D. Okay. Equal what, my kids, this one? Equal the matrix or the current vector 0, negative 1. Okay. Here you have, you can ask yourself, BD is a current vector or is a matrix of order 2 by 1. And 0, negative 1 also is a current vector or is a matrix of order 2 by 1. So, how can I conclude that B equals 0 and D equals negative 1? Simply because both matrices are equal. As they are equal, my kids, their order are also the same, 2 by 1. The first matrix BD, the second matrix negative 0, negative 1 also is a matrix of order 2 by 1, have the same order. So as they have the same order, means that you can equate their corresponding entries. Means B equals 0 and D equals negative 1. Means what, my kids? Means B equals 0 and D equals negative 1. So now, my kids, we found what? We found A equals negative 1, C equals 0, and B equals 0, and D equals negative 1. This matrix, grasped to this matrix, you can transform anything. So, the matrix as a conclusion, therefore, B equals 0 here, and D equals negative 1. B equals 0 and D equals negative 1. Why? Because both matrices are equal and having the same order. Then the next, as a conclusion, my kids, what we have, the matrix for an anti-clockwise rotation about the origin through 180 degree. Anti-clockwise, you can cancel this one because 180 either they are there. Okay. And about the origin 0, 0 through 180 degrees is what? Is minus 1, 0. 0 minus 1. Thus to this matrix you can now apply to work out the coordinates of any point. Okay. Here we have a triangle. Okay. 1, 2, 1, 4. 1, 2, 1, 4. Okay, 1, 2, 1, 4, negative 1, negative 3. This is the point that I will work with my kids. This is A, this is B, this is... Okay. We done that. Triangle AB has coordinates of 1, 2, 1, 4, negative 1, negative 3. Determine the coordinates of the image of triangle ABC in the what? In the rotation. In the rotation about the origin. This is the keywords or the mathematical vocabulary. Okay? Through what? Through 180 degrees. First of all, before trying to find its image, you can ask yourself which method you will use. Is it algebraic techniques or geometric techniques? Yes, the title of our lesson is what? Matrix transformation.
or matrices and transformation, or material that transform an object to its image. So you should use algebraic techniques, okay? And geometric techniques that just to checking if or to guess if your answer is correct or not. So now I'm gonna ask you, without let's say moving to techniques, algebraic techniques or geometric techniques, write me the matrix for rotation about the origin 180 degree. This one it will be what? Yes, I'm looking, I'm trying to hear your voices, my kids. I'm trying to hear your voices. Yes. What is the first entry? Yes. Is -1. Good boy. Then the second one is 0. Good. Oh, sorry, 0. So there we go. Like this. We thought -1 and this is 0. Then this 0, good, and this is -1. Why? That is the question. Why exactly? Because this one can be written as what? As cosine of 180. Then this one minus sine of 180 degree. Then this is sine of 180 degree, and this one is cosine of 180 degree, whatever be the angle. Okay? So this one, cosine of 180 is -1. Minus sine of 180 is -0. -0 is 0. Then sine of 180 is 0. -1 is cosine of 180. Okay, why? Because this is the unit circle. This is -1. This is 1. This is 0. This is -1. This is 1. This is -1. Okay. So cosine of 180 is what? This is 90 degrees. This is 90 degrees. This is also 90, so it will be 180. Cosine of 180 is -1. Then sine of 180 is what? This is the sine, my kids. This is the sine that lies on the y-axis, and cosine lies on the x-axis. So this one should be sine of 180 is 0. Okay, that's why here we should write 0, 0, and here -1, -1. So this is the matrix for rotation, yes? For rotation that can transform any shape to its image. Okay, let's do it. So we told that the matrix for rotation about the origin through 180 degree is -1, 0, 0, -1. You will multiply this matrix by the coordinates of this point to find the image. Okay, I will just write here -1, 0, 0, -1. Multiply by 1, 2. The next one, we have what? -1, 0, 0, -1. Multiply by 1, 4. Good boy. The next, -1, 0, -1, 0. I multiply by -1, 3. -1, -3. So just multiplication. Okay. This one multiplied by this is -1. Why? -1 by -1. -1 by 1 is -1. Plus 0 by 2 is 0. -1 plus 0 is -1. This one multiplied by this gives only -2. Why? 0 by 1 is 0. 0 by 1 is 0. Plus minus by 2 is -2. 0 minus 2 is -2. Hence that a of coordinates 1, 2, and maps to a prime of coordinates -1, -2. Okay. Good boy. The next. This matrix multiplied by a kind of vector 1, 4. Just the first way, the first step, I will try to multiply the first row by the first column. Then it will be -1 multiplied by -1 is -1. Then 0 by 4 is 0. -1 plus 0 is -1. Then this one multiplied by this is 0 by 1 is 0. Plus -1 multiplied by 4 is -4. 0 minus 4 is minus 4. Okay, just I will write now the conclusion that the B has a coordinates of 1, 4 maps to B prime of coordinates minus 1, minus 4. Good boy. Then, the next one, multiply the first row. By this one, it will be only 1. Negative 1 multiplied by negative 1 is 1, plus 0 by negative 3 is 0. 1 plus 0 is 1. This one multiplied by this, 0 by 1 is 0, by negative 1 is 0, negative 1 by negative 3 is 3. So I can write the coordinates of C prime, which is C of coordinates minus 1, minus 3, and C prime has a coordinate of 1, 3. Now, as a conclusion, in the rotation above the origin, 180 degree through, 180 degree, triangle ABC is mapped into triangle A prime, B prime, C prime, where A is what? Is negative 1, negative 1, negative 2. And B prime is negative 1, negative 4. And C prime negative 4, not here, I will make it here. And the last one, 1, 3. Okay? This one, my kids, how can you transform shapes in the rotation above the origin 180 degree? The next example, we have 4, 2, 4, 4, 4, 2, 4, 4, 4, 2, then 4, 4, then we have 2, 3. We have 2, 3. We have 3 points. This is C, B, and A. We will try to convert, or not to convert, to transform these points. Okay, what we do exactly? The matrix for rotation above the origin through 180 degree is what, my kids? Is minus 1, 0, 0, minus 1. Just multiply this by the coordinates of this point to find A prime, and then to find what? B prime and C prime. Let's do it one by one. So this is the matrix for transformation. Minus 1, 0, 0, minus 1. Multiply by what? Multiply by the first one is 4, 2. So minus 1 multiplied by 4 is minus 4. Plus 0 multiplied by 2 is 0. 0 plus minus 4 is minus 4. Then this one multiplied by this means 0 minus 1 multiplied by 4 minus 2. 0 multiplied by 4 is 0. Minus 1 multiplied by 2 is minus 2. Then, hence that, A of coordinates what? 4, 2 maps to A4 of coordinates, A prime of coordinates negative 4, negative 2. Okay? The next, we have negative 1, 0, 0, negative 1. Multiply by what? Multiply by 4, 4. Multiply by the coordinates of B, but try to write it as a current vector. Okay. So it will be 4, 4, 4, 4. Then just multiply, my kids. Minus 1 multiplied by 4, minus 4. Plus 0 by 4, 0. Minus 4 plus 0 is minus 4. Then 0 multiplied by 4 is 0. Minus 1 multiplied by 4 is minus 1. Is minus 4. Minus 1 multiplied by 4 is minus 4. 0 minus 4 is minus 4. So, hence that B has a coordinates of 4, 4. I will write it here. Maps to B prime of coordinates negative 4. Negative 4. Okay? Then for C, we have what? The matrix for rotation above the origin through 180 degree. Okay, it will be minus 1, 0, 0, minus 1. Multiply by the coordinates of the point C, right as a vector. It will be 2, 3. Good boy. Then just multiply this by that. Means we will multiply this by that. Minus 1 multiplied by 2 give us minus 2. Plus 0 multiplied by 3 give us 0. Minus 2 plus 0 is minus 2. Good boy. Then the next one.
0 multiplied by 2 is 0, plus negative gives negative. Negative 1 multiplied by 3 is negative 3. 0 negative 3 is negative 3. So I will just write C of coordinates 2, 3 has a coordinate maps to C prime of coordinates negative 2, negative 3. Okay, now as a conclusion, we can conclude that in the rotation about the origin through 180 triangle A, B, C is mapped into triangle A prime, B prime, C prime, where A prime has a coordinates of negative 4, negative 4, negative 2. And B prime have coordinates of negative 4, negative 4. And C prime is negative 2, negative 3. Okay, good boy. The next. Here we have another exercises. Okay. This one, my kids, is a homework. Okay. The homework is what? The triangle ABC has coordinates of 0, 2, B of coordinates 0, 4, C of coordinates 2, 3. Determine the coordinates of the image of triangle ABC in the rotation about the origin. Okay? Through 180 degree. Okay? Now we have another exercise. For example, now the point is A of coordinates 0, 0, B of coordinates 1, 1, and C of coordinates 0, 0, 3. Okay, I will try to transform these points in the rotation 180 degree about the origin. Okay, the matrix for rotation about the origin through 180 is what, my kids? We call negative 1, 0, 0, negative 1. I will multiply this by this one to find A prime. Then this by the coordinates of B to find B prime. Then this matrix by the coordinates of C to find C prime. Let's do it. Okay, this is negative 1, 0. Okay, 0, negative 1. Multiply by what? By 0, 0. So it will be 0, 0. Negative 1 by 0 plus 0 by 0 is 0 by 0 plus negative 1 by 0 is 0. So it will be, this is called the origin. A, no change. Why? Because it's the origin, okay, of my rotation. Then the next one, minus 1, 0, 0, minus 1. Multiply by what? Multiply, my kids, by the point 1, 1. So minus 1 multiplied by 1 is minus 1, plus 0 by 1 is 0, minus 1 plus 0 is minus 1. This multiplied by that, 0 by 1, 0, minus 1 by 1 is minus 1, minus 1 plus 0 is minus 1. Then I will just write, hence the coordinates of B of coordinates 1, 1, 1, 1, maps to B prime minus 1, minus 1. The next one, we have negative 1, 0, then 0, 0, negative 1, and multiply by the coordinates of C, but write this as a current vector to be 0, 3. Okay, so this one multiplied by this, negative 1 by 0 is 0, plus 0 by 3 is 0, 0 plus 0 is 0. Good boy. Then this one multiplied by that, 0 by 0 is 0, plus negative 1 by 3 is negative 3, negative 3 plus 0 is negative 3. Good boy. So just write this there. It will be C of coordinates 0, 3, maps to C prime of coordinates 0, negative 3. Now, as a conclusion, we can conclude that in the rotation of the origin through 180 degree, this is 180 degree, triangle ABC is mapped into triangle A prime, B prime, C prime, where A prime has coordinates 0, 0, okay, which denotes the origin, and B prime is negative 1, negative 1, and C prime is 0, negative 3. Okay, now, at least we see how can you rotate shapes, okay, through the, about the origin, through 90 degree, 270 degree, and what else, Ismail, about the 270 degree, good boy, and 180. Now we'll try to find how can you enlarge. We finished with the rotation part section. Now we'll try to move
how can you enlarge, say, Mr. Tayyib Ahmed, how can you, let's say, how can we work out the image of this? Yes, okay, general matrix. So, I reiterate, the above matrices are confined to angles that are multiples of 90 degree. Okay? For example, 90 degree. Okay, the multiples of 90 degree, my kids, are what? 90 degree, then 180, then 270, then 360 degree, of course, and so on. Okay? So, we told the above matrices are confined to angles that are multiples of 90 degree. If one of you, my kids, has to perform a rotation through other angles, there is the general matrix for rotation of theta, of the angle theta, about the origin in an anti-clockwise or counterclockwise direction. When theta, this is theta, an angle, okay, this is theta, can be any angle. The matrix for an anti-clockwise or for a counterclockwise rotation through theta about what? About the origin is this one. Cosine of theta minus sine of theta, sine of theta, cosine of theta. Okay? Just if the angle, for example, in the question, theta equal 90, okay? Equal 90 degree. So we just make cosine of 90. Cosine of 90 is 0. Okay? Sine of 90 is minus 1. Sine of 90 is 1. And cosine of 90 is 0. So this is the matrix for transformation. The matrix for rotation about the origin anti-clockwise through 90 degree. This is the matrix. For example, the point is 3, 2, for example. Okay? This is the point A. This is the matrix that transforms this to that, to the image. Just multiply this by that. It will be negative 2. Okay? And this by that, it will be 3. So, the image of point A of coordinates 3, 2 is negative 2, 3. Okay? And the rotation about the origin anti-clockwise through 90 degree. Okay? This is very important. Okay? The next one, my kids. We have the matrices for anti-clockwise rotation through 90 through theta. Theta is a given degree about the origin is cosine theta minus sine theta, cosine theta. Okay. If theta equals 0, the matrix is what? Cosine 0 is 1, sine 0 is 0. Sine 0 is 0, cosine theta is 1. So this is the matrix when theta, the angle is 0. When the angle is theta is 90 degree. If the angle is 90 degree, means what? The angle is 90 degree. Means that you will rotate a shape or a point through, let's say, you will, let's say, rotate a shape or a point about the origin anti-clockwise through 90 degree. So the matrix of this one, it will be what? It will be 0, negative 1. It will be 0, 1, negative 1, 0. Okay? This one is for this. This one is for this. Then, if theta equal 180, if theta equal 180, my kids, the matrix for transformation or for rotation about the origin anti-clockwise through 180 is negative 1, 0, 0, negative 1. Okay? And for if theta equal to 270, the matrix for rotation about the origin anti-clockwise through an angle of 270 is 0, negative 1, 1, 1, 1, 0. Why? Because just put theta here. Cosine of 270 is 0. Okay? Cosine of 270 is 0. Sine of 270 is minus 1. Minus sine of 270 is minus. Gives plus, gives what? Gives this one. 0, negative 1, 1, and 1, 0. Okay. Okay.